feel like an IT pro. All right, welcome to the webinar. And this webinar will be Daniel Campbell and myself, Sam Gambro. We are presenting specifically on how QIF can be used with 2D data, specifically 2D engineering documentation. So quick housekeeping. For those of you who aren't used to or don't often use GoToWebinar, there should be a toolbar. The toolbar will allow for the submittal of any questions. So as we get to the end, we'll certainly be looking for any questions, or if there's anything that needs clarification, please make use of that feature, and it'll give us the opportunity to see your question. I guess without further ado, I believe we are ready to go. All right, so I guess the very first question is, why are we in this state? How did we get here? And the reason, or at least my take on the reason why we have to have this meeting and why we are now clarifying the value of QIF for a 2D drawing world is we were very focused on MBD. We were, if anything, hyper-focused on MBD, on semantic data and how to use that. And the question sort of is, well, why? Why were we so excited about MBD specifically? And one of the reasons was model-based definition is very software driven. You can't use your older tools. You can't print things out. You need a software solution. So when engineering goes model-based, you need a software tool, and QIF gives you that answer, gives you the ability, or sort of gives you something to ingest in that software, gives you a path forward. So if you're going MBD, you need a solution. This was a solution. So it's not a case of, is this a better tool or a better mousetrap? This really is sort of a introduction to the only tool or a brand new mousetrap in the sense to solve that problem. So MBD needed an answer. This was an answer. The other thing is the digital thread, or sort of the ability to connect your data and use big data or use AI or machine learning. That's a very hot topic. It gets everyone in upper management excited. So with MBD, it gives you that digital thread, it gives you that digital twin, which helps feed that big push, that big drive, where you don't necessarily get that same opportunity with 2D. And the other big win with MBD is the ability to automate the flow of data. So that's a lot of savings, a lot of opportunity, ability to sort of streamline what you do, only have to do it once. And all those reasons were really why MBD was our main focus. And sort of taking a step back and going, well, not everyone's doing MBD. Why are we now talking about 2D? And one of the big things is MBDs, it's a journey. It's a journey, and we're all still working to get there. We're all still trying to get there, but there's a lot of legacy products still being made, and even for newer product, there's a lot of inefficiencies, I'd say, or a lot of lessons still being learned with MBD. So we're not quite there yet. We're still trying, but we still need a solution for today. Which brings us to QIF, and can QIF do 2D? And yes, it can. It was actually designed with that in mind, with intent. The standard itself has a lot of capability to ingest information from different standards, from different sources of information. So we'll actually cover a little bit of that today, but it's not being sort of reimagined to cover 2D stuff. It's always been there. And then the question is, why would I go and why would I spend all this time to get all my legacy stuff and try to meld it with something that is a model-based focus? And there's still a lot of opportunity and a lot of advantage one can use by using QIF to create a digital workflow within quality, even if your engineering data isn't fully model-based. So here's the sort of comparison of a current state and a future state, sort of a very big picture view. where we take a lot of the more common processes with quality and sort of show how the information is flowed out. In this example, the little guy running, the orange dashed lines are our current processes. And using the pictograms of paper, you see as you move from process to process and as you try to flow that data on, you lose that fidelity of the data. You continually lose pieces. You're recreating. It's like making a copy of a copy of a copy. Every step down, you just you lose a little bit. You end up with data that just can't really correlate that well to that initial data. Where our future state, we want to be in the future at least, is by leveraging QIF, using that digital flow of information and automating that flow from step to step. You maintain the richness of that data. You make it all the way down to the end, to the analyzing and reporting of that information without sort of getting granular or just losing that tie to the beginning. And one of the big advantages of that is that arrow going all the way back is you now start getting data produced by quality that can be used by others, that can be flowed back to engineering or to other groups, and allowing them to sort of ingest it and use it in a more automated, richer manner. So this breaks it down a little more. Sort of goes over our existing process with a lot of pen and paper. So nice example in the bottom left right there. And if we look at each process has sub-processes and has detailed information. And a lot of that information, there's overlap in what information feeds into it. So in this particular example, we have the FAI forms, we have creation of a control plan, and we have programming a CMM. And in all those cases, there's definitely duplication of information. And one of the interesting things is the level of data needed for each one isn't exactly the same. There's overlap. So for an FAI form, you don't need the geometry. Where the CMM program, you do. You need the geometry, you need that feature information. So with an FAI form, if you were to ask someone to say, hey, completely recreate the model and give me a bunch of features, they'd say that this is a waste of time. I don't need this. But if you go to a CMM program and you start asking for, hey, give me all the stuff I need to measure by hand, you say, oh, well, this is a waste of time because I don't need that. So there's overlap, but there is also differences between them. So because this is not exactly the same, and because of the way the information is entered, you get into this dead end of information. You make the FAI form, you make it in Excel. You can't use that in the CMM program. CMM programs don't read Excel files. So you end up in sort of getting into these data dead ends or sort of content cul-de-sacs where you go and you create the information by hand, but that information is specific to that process and you can't really flow it down to the other processes. So this should look a lot like the 2 slides ago. This of our ideal end state. The big difference here is we have transcribing of that 2D engineering data to enter this final process. And what we're doing here is a very common philosophy. We're trying to move as much as we can to the left. The difference with this is we haven't left the quality process yet. So we are no longer sitting here saying, move it all the way to the left, engineering owns it. We're saying, let's move it to the left as far as we can, and we'll just take the beginning of the quality process and we're going to take that data and we're going to make it model-based ready, even though the data coming in isn't model-based ready. So what's the value of this? What's the benefit? Well, in one case is that we're taking a lot of that information that we needed and we're only doing it once. So the FAI forms the control plan, the CMM program. It's all pulling off that same piece of information. It's allowing that information to flow back and forth. If you want to go and identify CMM steps in the control plan, you can now feed that down. If you want to make sure you didn't miss anything on a CMM program, or there's things that passed or failed and we want to populate our FAI forms, we can feed it back up. So now these steps can be more easily linked. And even though somebody might say, hey, why am I creating this full model? I normally do the FAI forms. Why do I have to go do the geometry too? It's because the CMM program needs it. So you're doing more work to create that than you do with any one individual step, but you're doing less work overall than would have to be done once all those steps are completed.
Could you
And
say
what
it's an upfront investment?
hey, I thought we muted you. Yes, no, you're absolutely right. It's an upfront investment, is that you are spending a little more time upfront, but the sum of time you're spending is actually less. And then it also enhances, in addition to that, in addition to saving time, what the real value is you allow for additional automation. You allow for a digital workflow. You allow for the creation of a model-based inspection workflow, which we don't have in the previous slide. And then not only does it allow you to be more efficient and use technology to be smarter, one of the big advantages is the block up here, the engineering requirements ready, is this is the same workflow that you will be able to use when engineering does create semantic PMI and you do have model-based engineering. So you're not investing in a new technology just for the 2D stuff while you're waiting for model-based. You're essentially creating your model-based workflow and ingesting that 2D information while you're in preparation for that 3D information, for that 3D model-based workflow. And then once you start getting it, I don't think anyone's going to have a situation where they'll be fortunate enough to say, oh, we're not making any legacy or 2D stuff anymore. We're just doing MBD now. If you do a system like this, it allows you to ingest both pieces of information using a single system. So you're not going to be sitting in there trying to manage two completely different systems for two completely different sources of engineering requirements. It allows you to build a single system and work all your different engineering requirements through that same system. So we talked briefly about this. We'll touch again on a lot of the items. The value of using QIF, of using a model-based inspection approach, even if you don't have model-based engineering requirements coming down. It does allow for a certain level of automation, especially we saw multiple steps where we would have to manually create for each step. It allows you to sort of do it once, do it to the left, and then to reuse that data. That said, level of automation is definitely improved greatly for model-based definition. So you're not going to get quite as much benefit, but you're still getting more benefit than doing everything manually. As far as characteristic management, QIF is a characteristic and feature-focused language. So schema, so as far as that goes, you start getting better visibility, you get more detailed visibility to the specific items within your parts. So you start getting the opportunity to be a little more focused at a more detailed level. Quick shout out to MBC, model-based characteristics, which is also a DMSC standard, that is also 2D and MBD compatible. So you still get the ability to leverage things like that, be it coming from a 2D or MBD world. And then as far as the transitioning to MBD, I mentioned before with the fact that you can have that workflow that works with both. This allows one to build that workflow. And I don't think anyone right now has a fully fleshed out MBD workflow for quality. There's a lot of pieces of it. There's a lot of ideas and concepts and theories. This allows one to start developing that and training their employees and figuring out what software is needed or the level of software, and get ready so when that MBD does come down and you don't have the ability to fall back and print things out or just bubble up a 2D print the old-fashioned way, it allows you to be prepared for it. So, and then once you do start getting the MBD flow coming in, you have the opportunity to use a single system, single operating process platform for the quality workflow while dealing with multiple sources of engineering requirements coming in. And with that, I will hand it over to Daniel Campbell.
Okay, thank you. Actually, can you make me a presenter, please? All righty. Yeah. So yeah. Well, thank you, Sam. So I'll get a little bit into some of the technical details related to QIF, like how this is actually done in QIF. And I mean, I will point out right now from the outset that a lot of this, if you're a QIF user and you want to use a QIF enabled software application to do your activity, you don't need to know anything that I'm explaining here. This is kind of getting down into the architecture of QIF, because I know that everyone here signed up is interested in that sort of thing. And so let me start. I'll give a little bit of background here about some real fundamental concept of QIF that we should establish up front. I can remind you about first, and that's features and characteristics. So features and characteristics, this is the kind of the big underpinning for QIF. And so features, what is a feature? The idea is, if we're looking at the MBD side of the world, a feature is where you would wrap CAD geometry with a feature, and that feature identifies some type of functional region of your part. And so in the example here, we have two CAD surfaces, two cylindrical CAD faces. Those two items are both referenced by a feature, and that feature represents a hole, a cylindrical hole. So that's a feature. That's what we would identify as a feature, and there are all these different types of features in there in QIF. And then we have characteristics. And so what is a characteristic? It's some type of a control that's placed on a feature. If we're talking about GD&T, that's some type of a tolerance, size, form, orientation, location, maybe it's a dimension tolerance. Maybe it's a surface finish, maybe it's a weld, maybe it's a note. There are a few different types of annotations that can be instantiated as characteristics that will reference a feature. And this is the way it works. A characteristic references a feature, and then the feature references the CAD surface, or really it references the product definition is what it is. In the MBD world, that's the CAD surface. And that might look something like this in an MBD setting. You have a characteristic and it'll reference this feature over here. And so this same idea can exist on the 2D side, a lot of these ideas. So first, let's take a quick review here. Let's take a step back and look at kind of all the different, these are 4 different steps on a company's journey towards full MBD, semantic MBD product definition. So first, we might be drawing only. So only in a drawing world. In that case, features need to be done manually. You'll reconstruct your features based on basic dimensions and things like that that you'll see on the drawing, and then you can program your CMM or your CAM tool or whatever, or your manually operated machining machine tool based on the drawing information. So that's where the feature information would be in the drawing only, and then of course the characteristic would be specified. Would need to be manually recreated from the drawing as well, and then of course there's no link to anything digital because there is nothing digital. So the next stage that people often get to is drawing plus a model, where the model is, let's say, call it a naked model. In other words, it doesn't have any annotations on it. In that case, it's possible to derive feature information from your CAD model, but your characteristics still are going to be, you're going to be doing manual work from a drawing. And then later on, you'll want to also link up those characteristics that you created with that CAD model. You'll need to do that linkage. Next, people will often go to a stage of getting into MBD, starting to make that step, but focusing only on graphical PMI. The interesting thing is, from this analysis, there's actually not a huge benefit over this side, which is where you can still derive your feature information, but your characteristics need to be recreated manually because your focus has been on graphical PMI. And then also, when you link up your characteristics to features, you'll need to do that manually as well. And then of course, the beautiful state that we all want to be in is semantic MBD. We have features digitally represented by a CAD model, characteristics that are machine readable, and the link between the characteristics and the feature is established and clear and machine readable. So these are kind of the various different stages that we want to be in on our journey towards this state of perfection. And so, just a couple of reflections about this with respect to QIF. First of all, what is the innovation of QIF? Why do people care about QIF? Why is QIF becoming such a big deal in industry? And the answer is that it's basically characteristics, which is the innovation of QIF. Digitally represented characteristics, which are linked to a product definition via a model. And so, if you really want to derive the value from QIF, it's because you're thinking about digital characteristics. And so, yeah, this far right column is the ideal state, but even here, you can get to a state where what you could do is you could digitize these characteristics. If you could figure out a way to make these characteristics digital, you could still manage what we call the bill of characteristics in a digital state. And by doing that, you could start to build up the internal processes, even some software tools that will allow you to start to manage a digital bill of characteristics, even from your 2D state, and it prepares you for 3D. And I could touch on that a little bit more in a little bit. So here's an overview of the architecture that we're looking at in terms of how to, when we're talking about a balloon drawing, what it would look like in terms of QIF. So at the top, we have the characteristic item, and this would be a balloon that is applied to a certain feature. So in other words, like if this is like a 3x diameter, a diameter applied to 3 holes, then there would be 3 characteristic items. It might be 22.1, 22.2, 22.3, something like that. The characteristic item references the characteristic nominal. Characteristic nominal, you'll have 1 characteristic nominal per annotation that you have. And so in that case of the diameter, the 3x diameter, you're gonna have 1 characteristic item, and it would be balloon number 22 in that case. And then in the 3D MBD world, we have our CAD data, and that's our product definition. It's called the product. In the world of 2D, we don't have that CAD, but the product definition is the 2D drawing. And so we'll see that in terms of references to a drawing, a drawing ID, maybe a drawing file name, a sheet number, a grid number, things like that, that will allow us to sort of drill down to this specific location in the product definition where we have that digital characteristic. So we could take a look at this. What we'll do is we'll look at an example of a tool that's out there that is enabled for 2D QIF consumption. This is Capvidia's MBD Vidia software, which obviously, as the name indicates, is good at handling MBD, but it also handles 2D product definitions as well. And so we'll take a look at an example quickly here. So where we're starting out is that the model's already been scanned and digitized. And so we have our list of digital characteristics here in this bill of characteristics. So now we already have all these characteristics in a digital form. So you can click on them. We know where that resides on the drawing. It'll zoom into it just like we saw there. In this case, we have this 3x diameter. So we'll see there are 3 balloon numbers. Here are the 3 balloons here, 22.1, 0.2, 0.3. And then if we look at the relationships here between all these items, we'll see that we have the diameter characteristic item 22.1, 0.2, 0.3. So we have 3 of those characteristic items. Those reference back to the characteristic nominal, which is shown there. That's just balloon number 22. We could see it here, the designator. We have this UUID and so forth, criticality levels, things like that. And then also when we look at the characteristic nominal, we can see how it references the drawing zone. This is sheet 2, grid H8 in this case. And that's the reference down to the underlying product definition, like I was explaining. And so this works for results as well. Characteristic measurements is a big thing in QIF. So we'll have an example here. We just kind of have this made up inspection result spreadsheet with 5 serial numbers having been measured, serial number 1, 2, 3, 4, 5. So we could bring that in, and now we have those results stored as digital characteristic actuals attached to our characteristics that we previously saw. So we can carry out all kinds of analysis and so forth. So we'll go ahead again and look at the relationships of all the data structures involved here. So what we're looking at here is this serial number 2. So this is called a component or an actual component in QIF. And this represents the results for that component called serial number 2. That is linked up to the diameter measurement, the diameter characteristic measurement, which has that result recorded of 10.01 to 3 decimal places. So we could see that there in the bill of characteristics. The diameter measurement links to the diameter item that we were talking about earlier, which is 22.1, and that links up to the characteristic nominal that we were talking about earlier, which is balloon number 22. And in there, of course, we see that designator, balloon number 22. We can see that on the drawing. We have the UUIDs, criticalities, et cetera, et cetera. So hopefully that kind of gives an idea of how you can kind of navigate this world of, again, underneath the hood, what we're looking at, that's a drawing. That's a PDF drawing under there. But once you kind of scan that and pull that into a bill of characteristics, you could start to work digitally with your data, which is a huge, huge benefit. So just kind of a recap of these data structures. Again, if you're just an end user, you don't need to care about this if you don't want to. But I know since everybody here is a big nerd, you want to know about this just like I do. So we have this actual component, and that represents the results for a given serial number. And then from there, we'll have a characteristic measurement, which would be the result, a specific result from that part that was inspected. The characteristic measurement references the characteristic item, which references the characteristic nominal. And that's kind of in general, the architecture that we're looking at. So just conclusion of like, what did we just look at? I mean, so even though we're not in the MBD world, there's still a lot of value that could be derived here, okay? Because we have our bill of characteristics, we have our quality plan, and we were able to manage some quality results, some actual measurement results. This is all in an easy to use digital format. We're not working with paper anymore or juggling Excel spreadsheets anymore like that. It's all linked up data. And then, yeah, I mean, the other benefit here is that you start to build business processes and you start to deploy software that works in the world of QIF and is used to managing digital characteristics in QIF, your digital bill of characteristics in QIF. That means that those same tools, it's the same, this structure of characteristics, characteristic measurements, items, nominals, and so forth. This is the same set of data structures that exist on the MBD side. And so once you start, building your processes around this type of structure, as you transition to MBD, you don't need to buy a completely different new tool set necessarily. I mean, a lot of the tools and processes that you could put in place, you can continue to use in an MBE environment, having kind of a single tool set for all environments. So in other words, starting to adopt this approach, in addition to the benefits you get directly from it, it's actually a nice bridge towards model-based definition as well. So last slide, just a little bit about some of the low-hanging fruits in terms of, if you want to get into 2D QIF, why would you do it? I mean, what are some of the values that you could derive pretty early on from it? I think the first one and the biggest one is, let's call it digital characteristic management, and that's managing your characteristics in a digital manner. A lot of this falls under what is called APQP. So, I mean, you have concepts that, you'll hear your quality people talk about in terms of systems that they're managing, of DFMEA, their FAI process, PFMEA control plans, carrying out statistical process control and things like that. So all of this can be, I mean, this is all based on implementing business systems to be able to support these workflows. And what better way to implement a business system than with some type of a digital approach? So that's, I think, the lowest hanging fruit by far, is just characteristic management. Next, there are some early workflows for using this type of sort of scanning and digitizing to QIF, digitizing a drawing to QIF, and then pushing it towards a CMM workflow as kind of a way to partially automate a CMM. What needs to be done is you still need to attach those characteristics to the feature that it belongs to, but it does eliminate the work of having to type in all the different characteristics. And so this is something that I've seen some early work on, and it could be a thing that might be a low-hanging fruit for you. And then the last thing is just thinking about characteristic management at the enterprise level. A lot of the PLM tools out there have the ability to manage characteristics, and even if you're not in an MBD world, you can again digitize your bill of characteristics and use your APIs and your PLM system to push your characteristics into your PLM system, and you could start to think about managing your bill of characteristics at the PLM level. which is kind of an advanced concept that's usually thought of as something that's done when you move to MBD. But again, there's no reason to wait until you go to MBD to start thinking about managing your characteristics digitally. So it's another possible low-hanging fruit for people to think about. And with that, I'd like to just open it up to questions. If anyone has any questions for Sam and I related to 2D QIF.
All right, so what I've done is I've unmuted everyone. You can, you're muted now, but you can go and unmute yourself and ask Daniel and Sam your questions. We certainly invite that as part of the conversation process. And I see in some of in the written questions that Evan had a kind of a detailed question. So maybe Evan, you want to jump in there and reiterate that question?
Yeah, hey, can you hear me?
Yes.
Yeah, great presentation. Yeah, I was talking specifically about the arrow that was going from the 2D engineering requirements to the, you had a box for the transcription. I think, Daniel, you kind of resolved that. I was asking if that's a human process. You talked about shifting the work left in the process. You do it once, you do it right, and then you're reusing, kind of similar to the philosophy of model-based definitions, setting it up to be model machine readable, all of that, compliant to industry standards. But I think you resolved that through the use of CapVidea's tool, right, as a specific workflow, right? Or is there an additional step that you were trying to communicate within that diagram? Over.
Daniel, you're still mute, but I can certainly answer the question too. It's a manual process, and being in the quality organization, the argument would be design should do it. And I've heard design say manufacturing to do it, and manufacturing said we're happy with quality doing it. So there's definitely a lot of finger pointing going on. But while we're sitting here trying to grow and develop a model-based solution, the silliest thing to do would be saying, I'm going to wait until we get another contract and we do model-based, and I'm going to learn all the mistakes after engineering's already made all their mistakes, and we have to wait for the next contract to fix it. So there's a desire or an effort to do all the things that we were hoping that design will be able to do the first right out the gate in the future. Now, as quality people, knowing what it is we're looking for, to start developing our processes and our workflows today. So yes, it's a manual process. Yes, we're going to have to take on a little more work up front, but the hope is we're already doing the work anyway. If we're more efficient about how we do it, we'll actually save ourselves time, even though we are still kind of filling that gap while waiting for design to eventually do it for us.
All right. Any other questions? Now's the time.
For anyone, I did type it in as well, but can you link to the characteristics from the 2D print and that becomes authoritative, but point to a reference model to aid in communications and stuff. So something that would be approved for purpose, either on the quality results kind of display and communication, or even in the manufacturing realm. They would have maybe a dumb IGES model or something, but the characteristics would be rooted in the authoritative drawing. Over.
Yes, and per the standard, there's nothing in the QIF standard that prevents you from doing that now. So you can have a characteristic, and Daniel showed, you can have the characteristic reference a drawing and a zone on that drawing. You can still have the characteristic linked to a feature, and you can have a feature that would then reference either an IGES model or a step model, or even just maybe a nominal CAD file of some sort. The issue I've seen is you're now taking two different sources of information and you're trying to merge them together. And I haven't seen any software yet that allows you to go and do that extra work. So it's doable in theory. I haven't seen it exist yet. Another thing I've seen people talk about, which is somewhat exciting, is instead of trying to manage things at a 2D level on a quality side, of almost creating an operations model and essentially doing that step that we just did from 2D to 3D at almost like a sub-CAD level, which has its pros and cons. So long-winded answer, yes, in theory it can be done. I haven't seen any software solutions publicly available that enable that just yet.
Thank you.
All right. So one thing I do see here is I see a lot of new names that I'm personally not familiar with, and you may not be familiar with the organization called DMSC, which is the Digital Metrology Standards Consortium. We are really the sponsors of this webinar and the developers of the QIF standard itself. If there's And this whole topic of 2D QIF really got started in one of our general membership meetings a few months ago. And in that meeting, we found out, and we've got a lot of people obviously involved with QIF at various stages, as Daniel pointed out. Which stage is your organization in? And you may not be familiar with what some of the things that the DMSC is doing today and plans to do in the future. And so those of you that are interested, tomorrow, actually by coincidence, is one of our general membership meetings for DMSC. In those meetings, we talk about mostly QIF, but DMSC does interface with a lot of other organizations, the Y14 ASME groups, MT Connect, PETUS, and other organizations as well. And it might be interesting to join one of our meetings. You don't have to be a DMSC member to join our meetings, and we'd certainly be glad to have you. So anyone that's interested, please send me a note or put a note in the chat so that I can send you an invite for the DMSC General Membership Meeting, which is tomorrow at 10 a.m. Eastern Time. So, any other questions from anyone? Okay, very well. Daniel, Sam, thanks very much for giving us some instruction here on a topic that is actually quite interesting and more value than we had originally thought, as we learned in one of our DMSC general membership meetings a few months ago. All right. Anyone else?
Thank you for having us, Mark.
Yep, super. Thank you, Sam.
All right.
All right. You will be getting, everyone here will be getting some sort of a message from the GoToWebinar folks. And as I mentioned previously, this session is recorded. So at some point you can even pass this on to some of your colleagues that couldn't make it here for this particular session. So thank you very much.
Thank you.
Thank you.
All right.
Bye-bye.
See you, everyone.
Thank you, bye.